Hello and welcome to everyone joining us today for Cognite's first manufacturing product tour. My name is Sliman Alab and I lead the manufacturing business here at Cognite. I'm delighted to be here with you, with my colleagues, and a panel of thought-leading customers from the manufacturing industry. Today, we'll show you how our software products can help you build an enterprise-wide industrial data model that's usable by many different personas across your organization and that addresses real-time use cases. These use cases span engineering, supply chain, and operations. They help you implement resilience, make better use of your assets, your materials, and improve the predictability, quality, and sustainability of your operations. But before we get started, here's some information about the product tour. It is a 60-minute session and will focus on product demonstrations led by our key customers and our own experts. This event is being recorded and the recording will be made available on our website, cognite.com. We want to hear from you. If you have a question, please post it in the questions box throughout the event and we'll answer them during a live Q&A at the end of the session. Okay, let's get started. We all know data silos are restricting how we can use data to create real-time decisioning. Everybody owns a share of blame for this situation. We software vendors have promoted siloed products for years. At the same time, the industry has adopted technology by process, by competence. So different teams, including operations, planning, R&D, data science, have been using different tools and approaches, unfortunately, to create their siloed insights and support siloed decisioning. There have been many attempts to fix this. There are strong manufacturing execution systems with enterprise-wide reporting capability, but these struggle to scale across the enterprise for decisioning. There are also enterprise data lakes, but these lack context and are unable to be used by anyone except a small group of experts. So, what if we combined the best of both solutions? What if we put the detailed context of an MES at the scale of an enterprise data lake? What the manufacturing industry needs is the operational digital twin. Let me step back and explain what I mean by that. An operational digital twin is more than just visualization. It's about contextualizing data, creating relationship between different data sources and data types in a way that aligns with how operators, managers, us humans think. It's about how we understand the assets, the processes, their performances, account for constraints, and access signals, events in real time to deliver insights. To give a real-world example of an operational digital twin, let's say I want to search for a certain machine by its name, whatever. The operational digital twin will provide real-time and historical time series data, alarms, events, open work orders, design documentation for this machine without needing to understand the naming conventions or database structures of any of the siloed source systems where the information resides. The operational digital twin breaks the dependencies between underlying source systems and how we want to use this data for decisioning. But building an operational digital twin is not the goal. The operational digital twin is the foundation that can power hundreds of use cases across operations, performance, sustainability, quality, and more. Today, you will hear much about Cognite Data Fusion, our industrial data ops platform. Cognite Data Fusion enables operational digital twins in the manufacturing industry. It does help this in 3 steps. First, Cognite Data Fusion makes data available by liberating it from different sources with its large library of APIs. Second, it makes data meaningful by using machine learning to put different data sets in context with one another. Finally, it makes data valuable by exposing it to your subject matter experts, data scientists, operators, and why not robots, to support decisioning and collaboration across your organization. We believe in openness. With Cognite Data Fusion, you can use open APIs to connect to low or no-code applications like for Power BI or Grafana, data science solutions such as Python in Jupyter Notebooks, and other industry standards tools such as simulators. With this open environment, your teams can continue using the application they know, but also adopt new solutions. Cognite Data Fusion is built to be your partner in democratizing data across your domains and help your organization move to more predictive and, when not prescriptive, engineering and operational workflows. During today's product tour, you will hear from Rémi Gauger, Cognite's principal technical consultant for manufacturing, and Ben Skal, our manufacturing product marketing director. They will illustrate 3 common workflows, which will show the opportunity to deliver business impact when industrial data is made available, understandable, and easy to use. These workflows are powered by data that has been contextualized into a single operational enterprise-wide digital twin. The first workflow will showcase our ability to create real-time descriptive insights for an enterprise view granular enough for site or assets. The second workflow will highlight the democratization of data to enable multiple business domains to create tailored insights. The third workflow will demonstrate how contextualizing data can be modeled to improve the predictability and quality of your processes. Finally, we'll give you a glimpse of the machine learning services that maintain the operational digital twin, speeding up your digital journey, while at the same time building trust into the data for an optimal user experience. You will also hear from several of our customers who will share their experiences with Cognite Data Fusion, from process and discrete industries. These include Ole Torrensen, Director of Digitalization and Improvements at Aker Biomarine, a leading biotech company. Rolf Tu, CTO at Inglas, and Aarbakke, which this year was named the smartest industrial company of Norway. And finally, Marit Torp, process engineer at Elkem, a large chemical conglomerate that is in the middle of a transformative digital journey. Before I hand it over to the team, there are 3 points I would like you to take away. First, putting data in the context is the critical success factor for digital transformations. Second, whether you are looking into a build or a buy, the software that will power your operation digital twin, think about scalability and how maintaining it will affect your time to value. Finally, we at Cognite have years of experience in supercharging operational digital transformations for industrial companies. We're happy to sit down and discuss how we can accelerate your company's journey. Thank you for tuning in. Rémi and Ben, I will now pass it over to you.
Thank you, Salman. My name is Ben Skal, and I'm the Director of Product Marketing with a focus on manufacturing here at Cognite. Gaining full visibility into manufacturing operations from the site level to the enterprise level remains a challenge. Key performance indicators and reports often exist within domains, think of operations or quality or scheduling, but it is often a very manual process when we think about collecting that information across domains within a single site, let alone having the ability to compare real-time performance across multiple sites. To achieve full operational visibility, we need 3 things. 1, a comprehensive enterprise view of our manufacturing operations that can also drill down to a very granular real-time view. 2, we need domain and persona-specific lenses so that users are only seeing information that's relevant to them. And third, we need to be able to have a single point of access independent of where information and applications are built. With that said, I'll now ask Rémi to demonstrate how we're creating enterprise visibility with our newly released Cognite Solutions portal.
Thank you, Ben. My name is Rémi Cauget, and I'm Cognite subject matter expert for manufacturing with more than 15 years of combined hands-on and management experience in chemical intermediate production, food and beverage, and pharmaceuticals. And today I will show you some of the unique features that our customers are deploying to optimize their production processes as they strive to be more data-driven. So Ben, as you mentioned, Cognite Solutions Portal is a real-time window into your operations that can be used across many business domains, from your shop floor personnel, your team lead, upper management, in order to access various reports or insights. Simply put, this portal allows different types of users to access the data-driven application sitting on top of Cognite Data Fusion and any other Cognite Data Fusion powered external applications. So this is not a Cognite dedicated environment, but really an open ecosystem approach where you can visualize all Cognite powered applications you have at your disposal, whether these applications are out of the box Cognite Data Fusion application frameworks, such as in-field or maintain, or customer-made applications and dashboards like a production standard board or preventive maintenance visualization tool, or even simulation tool such as process simulator or something even more specific like a risk-based inspection software dealing with internal corrosion, for example. The Solutions Portal is your landing page with all the apps you need available in a single pane of glass, creating visibility across operations, maintenance, engineering, supply chain planning, and even for upper management. Within the Solutions Portal, you can also create suites based on specific set of applications or personas, those with production optimization focus or quality assurance enablement, and so forth. What you're looking at is the holistic admin view of this page, and this view can be tuned for specific users and groups simply by granting access to a specific set of applications to a given user group. This is how we ensure that information is persona-based and tailored to the user. For example, a KPI or key performance indicator related dashboard showing the actual production cost on a given line is something that should be accessed by production or maybe site management, while a dashboard comparing electrical consumption and possible phase overload on a given MCC connected to a set of compressors, for example, that should be accessible by engineering and maintenance. So on this landing page, with administrator rights, you can customize these views. This way, everyone is only presented with the information relevant for their responsibilities.
Remy, can we also point out here that in addition to having an open ecosystem, we're also promoting self-service access to information. Specifically, I'm referring to the Cognite Hub link down there at the bottom. Through Cognite Hub, users have access to the broader Cognite community to share and exchange ideas, access to Cognite experts for help and requests, an extensive academy of courses to help upskill or train new users and onboard new users, as well as all of the product documentation. Now, this may seem obvious, but having all of this information easily accessible in a single place is really important to supporting this idea of self-serviceability.
Yes, it is. So now let's open one of the solutions on our landing page. We can have a look here at the dashboards which have been created from the data populated in our operational digital twin. In our true commitment to an open environment, we are looking at 2 Power BI dashboards and a visualization tool using Grafana at our disposal. The first Power BI dashboard is a production overview with all your data fully available to answer questions regarding production quantities, scrap, or process yield by simply clicking or selecting a given work order or a specific production line, which could also be extended to a process train or a new defined business unit. And this overview comes with the possibility to drill down and take a more detailed look at the production order or machines based on selected timestamp or range. In this second Power BI dashboard, we come with something fairly classic, in a sense that it displays the overall equipment effectiveness, or so-called OEE, for each manufacturing line in a nice single panel. However, there is actually quite a lot happening on the back end, which is not visible here. Being able to get the latest OEE in Power BI this way means that all the calculations are already linked to our operational digital twin. Elements like availability, performance, and quality parameters are all processed and aggregated inside Cognite Data Fusion. The same principle applies when taking a deeper look at the OE historic data or trends for each and every machine, as this information is now made easily accessible from Cognite Data Fusion with a very fast response rate. As I'm able to query several years of data equivalent and visualize that with only a sub-second latency.
Thanks, Remy, for showing how easy it can be to access persona-based information across a single site. We also talked about doing this across multiple sites. And so for a real-world example on that, I'm excited to introduce Ulla Thoresen from Aker Biomarine to show how they're using Cognite Data Fusion to create full enterprise-wide visibility into their operations.
Hello, my name is Ole Thoresen, and I am the Director of Digitalization and Improvements at Aker Biomarine. One of the biggest challenges we have at Aker Biomarine is overcoming the data silos across our end-to-end production process. Aker Biomarine is a fishing and biotechnology company with many moving pieces in our operation. They're extremely time sensitive as we work with organic products that can be highly variable and have very controlled useful life. We have multiple fishing vessels and onshore facilities that all contain important data related to our overall production. The opportunity for us extends past complete operational visibility, but it's about creating insights with our data that can be shared with the individuals in the field at our facilities. At Aker Biomarine, we're thinking about how to better collaborate around our data and ensuring insights created by an analyst in Norway, for example, can be shared with our operations team in Texas. With that in mind, we can take a look at how Cognite Data Fusion is enabling complete visibility of our production. Although detailed raw operational data is extremely valuable for both operators and production managers in our factories across our supply chain, being able to model on top of this, giving insights to these operators and production managers is adding another level of value. So these models that we're looking at here on the screen is a calculation of viscosity at a certain temperature, which is extremely important parameter for the operations. And to be able to do this with a central team of data scientists calculating and creating these insights, and then displaying it back to the operators, where you can both see the raw data and the synthetic time series on top of it, gives just a one-stop shop for the operators to view and do adjustments to the operations in our factories. Although detailed operational data is really valuable, sometimes it's difficult to see the forest for the trees. And that's why we've developed an asset health dashboard that connects directly from Insight into a Grafana dashboard that we've made. And in this dashboard, you can see a more binary view of the state of key assets in our manufacturing plant. And if you then dig into any of these assets, you'll then have a detailed view of all the different sensors that compose of this single binary view of that asset. This enables us both to, in a simple way, view a large number of assets and the health of them, at the same time that we can do detailed root cause analysis on the cause of malfunctioning assets. So you've seen a few different examples of how we use this data, and as we've shown, we like to visualize the data in whatever tool that is best fit for the user on the ground. In addition, we see that the value of this for one individual plant is great, but what we managed to create is a similar view across all our assets across the globe. And what that enables us to is to both get a holistic view across the supply chain, but we can also drill down to sub-second data on individual equipment.
Thank you, Ulla. We're now going to talk about democratizing data at the shop floor. How can we better create and scale insights that drive behavior changes? Subject matter experts need a way to generate insights that can be shared, acted upon, and iterated for improvement. Remy, can you show us how Cognite Data Fusion can enable an operational digital twin that will allow us to democratize data and build, and more importantly, scale insights?
Back to the solutions portal and the production suite, we have the ability to see the OEE, so overall equipment effectiveness, per line and per machine using Grafana. From this dashboard, we can quickly get an idea of which assets are performing well and which ones may need attention. These OEE metrics are all being calculated within Cognite Data Fusion and made available for broader consumption through Grafana.
Now, overall equipment effectiveness is a pretty common KPI. But what makes this special is not the what, but the how. Specifically, how we can calculate a metric like OEE for a single asset, but then put it on a pathway to extend it to creating a normalized enterprise-wide view of that metric. So what we're going to show you now is how we can extend the OEE metric from a specific asset to a fleet of assets across production lines and eventually across multiple sites.
So when we think about scaling, we should start by understanding how Cognite Data Fusion organizes and structures data to scale those use cases. Leaving the Solutions portal now in Grafana, I will now access the DataOps platform from my landing page. From the user interface, I can access the template part. So here we are looking at the templates which define all of the parameters we need to calculate this key performance indicator. Each row represents an asset we are calculating OEE for, and the columns represent the parameters needed for our calculation. The next point to pay attention to is that each column uses domain language, so we can see which parameters are associated with uptime, planned downtime, or power off, to name a few. The OEE calculation itself is running through a function, and the output of that calculation is being fed back and written back to Cognite Data Fusion, populating our first column titled OEE. This is a synthetic time series that is continuously being recorded, so we always have a record of the past performance.
Okay, so each asset in this template has a calculated OEE value that's running, the calculation's running in Cognite Data Fusion, and we're storing a historical record of that metric. Now, what I would like to understand is how templates actually saves us time when we think about scaling this OEE KPI to other assets.
The efficiency gain is delivered by two aspects. First, this template will run our calculation on any new asset added here. I will start by adding a new asset into this template, like a new robotic cell. This can be done manually in our user interface here, or it can also be scripted if you have many assets you want to add. I will simply call a new instance in the template, namely assembly cell number 3 here. I will select this new machine and add it into the data model. Let me rename the first column here just for the sake of clarity. As soon as this asset is added, you can already see that the AI matching system has started making associations. The only thing left for me to do with this template in order to have it updated is to quality assure the suggestions and approve them all. Very simple. Now, the real efficiency gain comes from the fact that every template uses an AI matching algorithm that is referencing our operational digital twin that already exists within Cognite Data Fusion. And because those relationships between our data already exist, the matching algorithm will make recommendations on which parameters we need for our OEE calculation based on the pattern of the other existing asset in our system.
So instead of having to manually select every parameter we need for our new assets, the template is actually automating this process for us in making those recommendations.
That's correct. Now a subject matter expert that knows the data can of course confirm that the matches are correct, but I do not need to manually look up and populate this template to calculate this key performance indicator anymore. The only thing I need to do is approve the recommendations to get my template populated and automatically updated. Now everything is in. So let's assume that the 3 machines are part of the same factory. Assembly in this case, but it could be extrusion, injection molding, grinding, milling, right? When I go back to my visualization layer, they should be in the dashboard. So let's check. Yes, I have the 3 machines. What I need to avoid is having disparate tables, graphs, or apps, which must be manually updated in multiple places every time I make a change. By this I mean that if we have 50 machines, I need an easy way to see them all. I don't want to see 44 here and miss knowing that I have 6 others somewhere else. Furthermore, if I know that I have 50 machines available, I want all machines to come automatically. I do not want another round of point-to-point connection. So what I will do now is first select the refresh rate to 10 seconds, and I will start adding more machines into my template and eventually my panel. So back to the template, I will add 3 new machines. I will select assembly line A, B, and C, which are available. They could be coming from another part of the factory or from a different site using a different PLC or SCADA system. So let me select assembly cells A, B, and C from the search function, and let me rename the corresponding columns here just for the sake of clarity. So I now have all my new suggestions automatically generated here. I just need to quality assure them and approve them. Back to the visualization panel, the newly added machines should all be displayed there. And here they are, done completely automatic. Once again, there's only a very thin layer of processing done in the visualization part. All the data transformation, unification, contextualization, all the heavy lifting, if you will, which usually takes a lot of time, is done in Cognite Data Fusion. Meaning that the associations we approved in the user interface are not just only available for this visualization panel alone, but for all the other applications using that data. This may sound trivial, easy, straightforward, and obvious, but it's actually not the case. Today, if you are not using Cognite Data Fusion, the automatic association that we just witnessed would take a lot of work and a lot of point-to-point connections. For example, if this data is also used for root cause analysis, preventive maintenance, or statistical process control for aftermarket services, it would now also be available. With the template now enabled, additional machines, production lines, business units, and sites can be added on the fly. That's what we call generating value at speed and at scale.
Beyond this use case, how can we extend the functionality of templates to other use cases or applications?
The reason this functionality exists with Cognite Data Fusion is to deliver more insight to the operators that actually make the decisions and run the equipment on the shop floor. In this case, we are focusing on an equipment key performance indicator, but this approach could be applied to different indicators such as conversion, selectivity, or yield monitoring for the chemical industry, or mean time between failure indicator for a machine supplier focusing on aftermarket services.
Thank you, Remy, and this is a great transition into our next customer use case. Aarbakke is one of the world's leading machining companies and was recently named Norway's smartest industrial company. I'm excited to introduce Rolf Tu, the CTO of Aarbakke and Ignos, to talk about how they are democratizing data to provide operators information on the shop floor.
Hello, my name is Rolf Tu and I'm the CTO of Aarbakke and Ignos. A critical moment for us in our digital transformation is when we realized that technology alone does not drive improvement. People do. That's why we think about Aarbakke as a learning factory, where we are capturing the best practices and using it to improve our operations overall. We have always had lots of data, and with Cognite we have been able to contextualize and use it throughout our factory. We have developed solutions impacting production, maintenance, quality and more. And today I'd like to share a few of those solutions with you. Okay, the first use case I want to show is a use case that we made for sustainability. Our customers and our company is really concerned about the footprint of our manufacturing, and then we realized with all the contextual data we could actually structure and find how much is each machine emitting and each product, and even down to each process on manufacturing. And here you can see a way of approaching the data from top level down to choosing one product, and you can see that total emission on this production was 32.49 kilos, 1.76 per part. And if you compare that to US or EU, you have significantly higher numbers. And you could also even see different process steps. Like this one is the machining, which is the most energy consuming. And then we move over to CMM, which is measuring the part, which is not consuming energy at all almost. The next use case I want to present is about utilization. The backbone of understanding how a factory is performing is of course to have good KPIs to see how you're using your machines. So here you can see an overview of all the factory, the performance of all the machines in the factory in February this year. I can show you on a more detailed level by going down into a group of machines to compare them with the utilization of the complete factory. And from there we can see a lot of different states on the machines that gives us rich insight in what is going on when the machine is not running. The most important part is of course to understand what are the activities that the operators have to do while the machine is standing still. It could be searching for tools, it could be faults on the machines like alarms or so, it could be finding specifications and drawings, and we need to make sure that we provide the data for the operators to really improve. And if I go down to one machine, you can see an even more detailed picture of all the states that this machine has had, and also you can see a comparison for this machine towards the complete factory. If you look into this machine, you can see all the products made on this machine, the different states as mentioned, and what is actually going on here. We can also filter down on to see which customers are we most efficient on and what are the trends. Here you can see the trend lines from OEE, machine utilization on work order, and different KPIs that helps the managers and not at least the operators on the floor to understand what's going on the machine. Going into one of the apps regarding the alarms that you saw earlier, you can see what the operators are seeing here. They see a total number of alarms, they can see the warnings, they can also see the duration of the alarms and the amount of alarms coming from all machines. They can go over to see faults, which are the alarms that actually stop the machine, and you can go into one of the machines to really see the details. So if you go into this machine and you select one alarm code, you can see when the alarm occurred and what actually happened on the axis of the machine. You can see it synchronizes data from different sources like sensors, the control system, and also the ERP system to give you knowledge about what's going on. So if I select this machine, I can see a list of alarms going on a machine, and I can see all the axes, all the loads, the feeds and speeds, every insight that the service engineer needs to see what's going on when the alarm occurs. So you can see how the axis performs here, and also you can see the flow of everything going on in the machine. So this is really a good tool for the operator to understand what led to this fault, and also to explain for the service engineer and go back retrospective and see what happened. The final app that I want to present today that we developed in the front end for use on the shop floor is the app concerning the utilization of the machines. This is a key indicator of how our measures are performing and how the machines are performing. Here you see the states of the machines at this time in Aarbakke factory. You have all the machines. It looks like they're on a lunch break because a lot of them are in idling. But if I choose one machine, I can go in and see more details. So here I can see the details on one particular product run through that machine. You can see the states during the time of manufacturing of this product. You can also see what impacts the utilization go up and what impact is going down. You can see the total utilization on the green bar and the different states of the machine during this work order on the bars below. This app gives insight to the operator how he can influence the utilization of his machine, and he can also, if he wants, compare to other machines, other shifts, to really see how he is adding value to the company. The applications you have seen now is part of the solutions that we have developed in Aarbakke. Aarbakke has had great success with these solutions, and we have actually managed to increase the utilization of the machines with 10%. That equals 40 million NOK on a yearly basis from Aarbakke at the current production rate. At the same time, we have reduced number of machines by 10%, going from 50 to 45 machines, and also increased capacity with 20%. This really tells the value of using data in a contextualized and good way. So Aarbakke decided then to sell all the IP of these products to a new company called Ignos. Ignos is a company that's going to make these applications available for manufacturing industry worldwide. We are looking forward to bringing this to the market in partnership with Cognite.
Thank you, Rolf. For our final workflow, we're going to show how Cognite Data Fusion can contextualize real-time operational data to help us improve our product quality. Specifically, we're going to show how a batch process manufacturer can use an operational digital twin to detect anomalies, perform analysis using no-code tools, and build more predictive quality assessments.
Thank you, Ben. To continue on that subject, we can take a look at this example, now focusing on batch processes. So here we are looking at all of the batches processed in a single bioreactor. The data is contextualized and unified in Cognite Data Fusion, and for the sake of visualization, I am using Grafana to access that data. From this view, we are able to see the data per batch over a chosen time frame, in our case 1 year of data, available in an instantaneous way. The main advantage being here that you can easily browse your data in one single panel for a wide range of fields. What I like the most here is that the information displayed is broken down per batch with a description of the accumulated data per batch, and that's something which is not directly measured at the plant, so there is a lot of value associated to it. All that data is processed using Cognite Data Fusion, and there's actually no need to do that in another server or edge device. Now that we have looked at the 10,000 feet view, let's drill down a little to see dosing phases during these batches. I may already have the total accumulated dosing, but the dosing profile for each batch can also be very impactful in terms of quality. What I want to see now are the dosing values coming directly from the flow meters, which I can add to my graph. I can create queries looking for a time series, but I can also do that from a root asset perspective. So here I do not wish to keep this root asset perspective view, but I would rather stick to the time series I already have with the acid, base, sugar, and oil feeding rates. So I will save that for now and return to the other panels. What I will do now is visualize accumulated meters value, something which is not measured at the plant. So here again, there's tons of value with this one. To do this, I can create a synthetic time series from my previous queries. I can copy this graph and transform the data with a simple totalizer. What I will then do is start by duplicating this panel, which is here now. I will edit it, change the panel title with dosing totalizer, for example. But the most important thing is to go to the Transform tab and simply add a calculation. I will thus select this Add field from calculation with acid, base, sugar, and oil parameter, and I wish to visualize and only visualize the total only. So let's just hide the rest, previously isolated meters, to simply visualize the totalizers. There are many reasons why the subject matter expert may want to visualize that aggregated data for the dosing lines. One of the reasons could be to simply draw a comparison between this synthetic data and reading at the plant, like the load cells that would be reading under the reactor. But you could use that to visualize other deltas, giving hints about a potential leak, or even worse, maybe giving an indication of a cold rupture that could be contaminating the batch. So one thing which is worth checking, if your data source can support this, is to visualize event-based information, such as start-stop sequences in our cases. Let me first hide these panels, like so. This visualization can be done in the annotation page found in the settings section with only one line of code. You then simply need to use the toggle button, which is located here, to overlay the batch's start and stop events. Let me select the properties panel and activate that, and there you go. If you don't have enough data to support that or cover all your time range, you can always zoom in like so. This makes data interpretation a lot easier if you have it at your disposal.
Now that we've created a batch-oriented view of our data, how can we use this to better control our product quality?
So controlling product quality becomes much easier as we overlay thresholds onto our visualizations layers. If I keep working on the same panel, the panel I just used, which is a plot showing how much oxygen got dissolved in a batch, I can add specific thresholds to visualize warnings and critical areas. And that I can do for each and every batch. Let me just remove the annotation and let's set 16% as critical and 14% as warning for those thresholds. So we actually have an application dealing with alarm monitoring as well, called AIR with Cognite Data Fusion. But this simple feature makes visualization quite elegant. So taking it to a higher level, we can further verify the quality as we compare the expected results from our simulator with the actual profile coming from the historian. By overlaying the time series with the expected simulation result, we have a fast delta visualization on all the parameters. If I zoom in a little bit here, in our case, there's a complete match between the historian and the simulator, so we can be fairly confident in the quality of our batch.
Now I'll ask the obvious question here. What happens if we get an alert or spot an anomaly when we compare our real-time operational data to the expected data from our simulator?
If that is the case, we can create an annotation on the fly directly in Grafana, just like so. I can select this point, which is over the critical threshold we earlier defined. I can just relabel that with FTR review. So I'll just put FTR for first time right. And this annotation will then be written back into Cognite Data Fusion automatically, meaning that I can later on go back to the contextualized data and start analyzing that event when I have the time. Such analysis can be done directly in Cognite Data Fusion user interface, but I personally prefer looking at time series in a tool that we call Charts, which is a part of Cognite Data Fusion. Chart is actually an explorative low-code, no-code tool where you can modify, combine, and transform your data as you see fit. In order to illustrate that, I already prepared a link into Charts for an isolated batch, and from here I can use the existing time series and perform calculation to create new synthetic time series to analyze key performance indicators, for example, or simply derive selectivity index for the process. So what I will do here with this data subset is simply create a new function using the pH values that we have here. First thing I'm going to do is hide the information I do not need. namely all the flow rates and the concentration profiles. And now I will create a new function with the only parameter I'm interested in. I will use pH as a source and do a simple smoothing of that parameter. For that I need an operator, and I'm lucky because I have a lot of operators inside charts. I will select a simple convolution, which is some kind of filter. I will actually select a Savitsky-Golay filter with the following parameters. And then I just need to link the blocks together, and there I have it. I have my new function. The other interesting element here is that I can also play with the visualization part too, stacking plots or merging units. The operator library I used in chart is actually very large and covers lots of disciplines, ranging from mathematical functions to more specific statistical tools, which is great, because this means that I can start exploring the data in a very powerful yet elegant way. No need to use Excel or Power Pivot anymore. Everything is there in real time and contextualized.
What about a more advanced user? Can we automate the process of creating batch reports so that we have an easier way to verify that we meet our expected product quality?
Yes, if you want to take a deeper analysis level, it's also possible to access the data from Cognite Data Fusion via Python SDKs. This approach opens the door to the creation of a complete batch report with all the dosing steps, all the production states described in the standard operating procedures, and a visualization of both GMP parameters like pressure, temperature, and flow rates, but also quality specification such as pH, viscosity, final product concentration, and all the Raman spectroscopy data, to name a few things. A data scientist can quickly retransform all the events into time series and plot them as such. So you now have your full batch report with a few lines of code because all the data is unified and linked in Cognite Data Fusion.
Thanks for a great overview, Remy. While this example was focused on ensuring product quality, this could easily be extended to environmental, social, and governance programs. To continue on with this idea of the importance of product quality, I'm excited to introduce our next speaker, Marit Torp from Elkem. Elkem's a leading provider of advanced material solutions. And today, Marit's going to be sharing how they are using Cognite Data Fusion to improve quality and reduce waste in their facilities.
Hello, my name is Marit Torp and I'm a process engineer at Elkem Carbon Solutions. Here at Elkem Carbon Solutions, we produce electrode paste and specialty products to the ferroalloy, silicon, and aluminium industries. One opportunity for us is to increase the predictability of equipment maintenance in the milling step of one of our production processes. Previously, we used planned maintenance. If we do not perform maintenance at the proper intervals, we risk degraded product quality that can result in significant off-spec products, resulting in loss of more than 100,000 euros. With Cognite Data Fusion, we were looking for a way to predict the state of this milling equipment to eliminate off-spec products while optimizing our maintenance schedules. We have different data sources. These are tags from the control system, typical time series, data from the maintenance system, and data from the laboratory system. Before, there was not an easy way to combine all these data sources into one visualization for doing, well, both production follow-up or, for example, when we are performing RCAs. Now with Cognite Data Fusion, we have a common platform where all the data is collected. As you can see here, we have different parts of the CDF or Cognite Data Fusion. And this is where we can explore our data. We have put up an asset hierarchy. For now, this is the milling step, the ramming paste that we have been looking at. And here you can choose, for example, vertical mill. And you can see here you have 7 assets under the vertical mill. We have 22 time series connected to these assets. And we also have events. And you can add files like PNIDs, and they will show up here. So everything is contextualized and kind of put together. Also, you can use filters and search for certain assets. Then we have the time series. Also here you can search or use filters. So maybe you can say, for example, I would like to look at all time series connected to the filter 15. And if you press one of them, you can see that you get the data here, and you can choose like how far back you want to look at them. Here we have information and metadata on this time series, and also what asset it is connected to. Files, as mentioned, could be like PNIDs or different documents. For events, it's for us mainly work orders from the maintenance system. Here also you can choose to look at what kind of a maintenance, or maybe for what equipment you're looking at, or what work you want to do, or of course time intervals could also be created time and updated time. We have added some 3D models here of our mill. We have created 4 different dashboards for different personnel in our facility, ensuring that all relevant data is easy to access and ensure that we have smooth operations. This dashboard is the one developed for the process engineer. Here we have handpicked just the right data to give the very best overview of the process. It could be raw data from the control system, filter data, or maybe synthetic time series we have created in Cognite functions. There are so many opportunities, sky is the limit. A feature that gives a lot of value is the possibility to show events on the time series. If we toggle these buttons, we will get lines or areas in the diagram showing the corresponding time for the event. In this case, a visualization gives me information on when a certain type of job has been done in the milling system. A huge improvement from before. We also imported historical data into Cognite Data Fusion, which allows us to create state detection models which gives us an early warning when there's something in the milling process that is abnormal, so that we can respond quickly and ensure that the product quality is not affected. The results of the models are shown in the dashboard. Here you can see the 3 models that have been developed. We are running our machine learning models within Cognite Data Fusion, making it much easier to work with the large amounts of data being created. It also gives the ability to make modifications to the model as we gain clearer insights with Cognite Data Fusion. Now that the solution is up and running, we can make continuous improvements to the state detection models, making them more accurate over time as more data is being processed. This brings us to the next and last tool, Cognite Air. In Cognite Air, you can create and maintain your own monitoring tasks. For each existing monitoring task, you can easily check the details, you can edit the details, and you can explore the results over different time intervals. When creating a new monitoring task, you can easily access several standard tasks and models ready for use. Our process is 24 hours, and as our operators do not survey the process at all times, it is crucial that they get a notification telling them when the mill system is unstable. This prevents us from running an unstable production process over longer time periods. Another aspect that we considered while evaluating Cognite was their e-learning offering. During COVID, we learned that we no longer needed to have on-site in-person training, as long as our vendors have self-paced training that we can use for our own employees. Cognite has a library of self-paced e-learning that we use to onboard our own staff. They also have learning tracks already in place, so it makes it simple to decide what training to take if you are a data scientist or a process engineer.
Thank you, Marit. All of the use cases we've seen here today have been powered by an operational digital twin built using Cognite Data Fusion. As we've come to the end of the demonstration portion of today's product tour, I'll now pass it back over to Sliman to do the wrap-up and lead us into some Q&A.
Thank you, Ben. As we close, I want to give a sincere thank you to Ole, Rolf, Marit, and the team for sharing their perspectives. To recap today's session, we believe manufacturers must enable many domains to create operational visibility, tailored decision-making, and move towards predictive prescriptive operations. Cognite Data Fusion has a unique AI-based contextualization services to create your operational digital twin. With our open ecosystem approach, your teams can access the data they need to cross-reference, build the workflows they require in order to enable the operators. If you would like to hear more about Cognite Data Fusion and our offering, please feel free to reach out to me directly or contact us through our website. Now, I would like to again remind you of the 3 takeaways. Putting data into context is a critical success factor for digital transformations. Think about scalability. Think about how to maintain it in order to affect positively your time to value. And again, please reach out to Cognite and really learn from our experiences in enabling digital operations and transformations. Thank you. With that, let's get to questions.
Yeah, sure. Do we have any questions in the field?
I don't see much on my end. Ben, on your end?
Yeah, sure. So we've got one, Remy, I think this is up your alley, but it has to do with source systems. So what source systems do you connect to, you being Cognite, and do you connect directly to equipment?
Yes, so when it comes to connection, the short answer is that we can connect to a lot of systems. In order to be a little bit more specific for the audience today, so we could say that when it comes to the discrete manufacturing environment, so we can directly connect to machines, PLC, HMI levels, SCADA, but also MES, CMMS, and even ERP systems. So this is a little bit vague, but in a sense, when you do connect to one of those systems, we have very powerful standard extractors that we can connect directly using OCSoft Pi or OPC UA industry protocols, and that makes it easy for us to ingest the data, transform the data, and create relationships between this flow of data across different silos. And that's very powerful. This is one of the unique points that we see with Cognite Data Fusion and which is recognized.
Excellent.
And do you have another question?
Yes, and so I can take part of this one too, but this is sort of back to the do-it-yourself, right? And it says, can our organization build more custom solutions with publicly available services and support these types of initiatives internally? Mm-hmm. Do you want to take the first crack, or do you want me to?
No, feel free just to go ahead, Ben, if you have it.
Yeah, so this is really about time to value, and when you think about these types of data sources and what you saw today, the industrial data environment is incredibly complex. And so Cognite Data Fusion is managed to handle that complexity. I'm thinking about things like high frequency and high volume of time series data, the ability to integrate, and we didn't even really get into today, contextualizing PNIDs and 3D drawings.
Yes.
But what this really comes down to at the core is how long is it going to take you to build and scale out use cases? Trying to do this, build all these pieces and using open services yourself, typically we see takes 6 to 12 months before you have operationalized deployments. Most of our projects, we target being operational in 8 to 12 weeks. So this is really about accelerating that time to value.
Yes.
Excellent.
Spot on.
Spot on. And I think I agree with you, Ben. And I think whether we're thinking of, as I said earlier in my introduction, whether we think of a make or buy, I think Cognite Data Fusion needs to be considered in both scenarios, right? As a way, indeed, to consolidate all the data, contextualize the data, and indeed accelerate, right, the deployment of applications.
Yep. And the last question that I have in front of me has to do with maintaining and populating that operational digital twin. We showed a lot of the use cases and how it can be used once you have that data contextualized. But Remy, can you talk a little bit about how we actually create and populate the digital twin?
Yeah, I can take a couple of minutes on that. So that was basically displayed in one of the, let's say, flows that I had with the template, showcasing how Cognite Data Fusion can be used to scale use cases. And that's basically what's powering all the use cases that were presented by our 3 customers as well. But if you take into consideration this native cloud environment where we are working with large amount of data, basically once you have the data inside Cognite Data Fusion, our proprietary associating or referencing AI algorithm will just create the relationships across the different silos for the data that you have pushed into the system. So this is what will help you basically maintain that system, because this is going to be done automatically whenever you are just pushing more data in the pipeline. So you don't have to go through another round of point-to-point connection, something that you usually have to do if you're not using Cognite Data Fusion, and that's very cumbersome.
Yeah. Great. I have a couple of questions in here from Chase. How does CDF work on the top of SAP plant maintenance systems?
Okay, so I can take that one. So this is a good question. So like I said, so we do have the possibility to connect to CMMS system. So SAP, SAP module, Maximo, Plania, or any other CMMS. What usually happens is that we need to create the specific data extractor connecting CDF to your SAP module. And then we are able to pick up all the work orders inside as events inside our DataOps platform. What is interesting is that then you will be able to connect those work orders together with time series so that you can draw analytics on top of that. So you don't have to work in silos, but you can work across silos. And that's a very elegant way to process your data.
Absolutely. And this would be relevant if it is, again, as a follow-up, what gaps does CDF address in relation to EAM systems, be it SAP, Infor, and I would assume combination of all these type of systems as well.
Yeah, exactly. So the more systems you have put into CDF, the better visibility you will get with your data flow. So if you get the chance to actually connect quality management systems like LIMS, historians, SCADA, CMMS that we just talked about, and possibly also warehouse management systems, which is right down your alley that you know very well, Sliman. Absolutely. So that would be even better because you can go beyond the 4 walls of the factory.
Another question from Edwin. Hey, Edwin, I may have missed this, but how does CDF support with aligning information across data sources? And I think, let me get as an example, the PNID refers to, let's say, P700, but the point in PIs is very different. So how do we do that linking?
There are some, if the tagging philosophy is, let's say, coherent, let's say, robust, and valid across all your assets, then this is going to be an easy match for our AI-powered, let's say, matching algorithm. Because the referencing between your physical assets that you have digitalized and your resources, files, time series, and events, that's going to be an easy match for the association. But if it so happens that your data or your referencing is not, let's say, very well structured in a way, then we can transform the data so that the linkage between those two will be made, let's say, automatically, more or less. We assume that 90% of the associations are done automatically with our systems, and the rest has to be done and approved by SMEs only one time. And then this is the algorithm is improved by iteration after that first run.
So it's like...
Can I add to that?
Absolutely, Ben.
Yeah, so this is the problem. This is really the core problem that we're trying to solve with the AI contextualization services. We know that the nomenclatures across different source systems are different. They're not going to be the same, and it's going to get even more complicated as you start thinking about expanding that to new sites. And so using those services to understand how the pattern is created between an asset hierarchy and a nomenclature that's going to be on a P&ID drawing is really what we're trying to solve when we talk about automating contextualization.
Excellent. Which basically leads to the next question coming from Peter. Hi, Peter. Is the matching trend, using trend information from different tags, or is it just by naming convention? And I think it's...
From naming what?
Is the matching using trend information from different tags, or is it using just naming conventions?
You have the possibility to customize the system. So if you have a one-to-one relationship between a tag which is present in your physical asset and in your time series or events, then the matching will be done automatically. If you don't have that, then you can customize it so that you create yourself a path for the algorithm to understand the relationship between those elements across silos. It can be between two different systems, but it can also be across different business units and scale it across different sites as well. So it's very powerful. You can customize that.
Yeah. Yeah, what you mean by customize, I think it's configure. And what we mean by that is really being able to do semi-automated matching with scoring techniques that then with machine learning will enhance, right, over time.
Yeah, and to continue on that, all this, let's say, customization, transformation, allowing you to connect and contextualize that data. So we have a very strong data governance and data lineage inside this data platform, so CDF, Cognite Data Fusion. So all the transformation and, let's say, the path, your data flow across the system, everything would be recorded and available for visualization or sharing if you have to do that with the authorities.
Excellent. Excellent. Thank you, Remy. Ben, any other questions on your end?
Nope. That's everything that I see.
I have another question here again. Using work order information across multiple facilities, is it possible to extract analytics? As in, we see that in facility XYZ, the model of pump is undergoing much more or less maintenance combined with the impact of performance?
So, yeah, short answer, yes.
Absolutely.
Long answer, there are many different ways of doing that. And I'm saying this because we have deployed different use cases with our customers on that. So use cases that we have scaled across their systems. But just to put it simply, if you're looking at this question from a statistical process control point of view, you always have the possibility to check between work orders which are reacting, let's say reactive work orders, and preventive work orders. If you have the possibility with Cognite Data Fusion to collect those work orders together with the historian and possibly also with a simulator, then you can create an environment where you will not react, but you will be able to do condition monitoring and predictive maintenance on those assets for pumps, heat exchangers, valves, compressors, you name it.
Any type of assets.
Yes.
Absolutely. So that's really the power of CDF, right? Being able to be enterprise-wide as being one semantic data layer, right? To support all type of decisioning, being predictive maintenance or any type of other decisioning that you would like to deploy across your operations, and why not engineering and operations?
Yeah, exactly.
Good. I do believe I have here exhausted all the list of questions. So with that, I think we are a few minutes over time, but I do believe that, or I hope that you all got value out of the session today in understanding Cognite's value proposition when it comes to not only contextualization, but overall a data ops solution, right, that can accelerate and make your digital transformation robust. Thank you all for your time. Thank you again for the speakers, and thank you again for the questions. Thank you for attendance.
Thank you.
Thank you. Bye-bye.
Bye-bye.